Good morning everyone. In this episode, we are going to discuss few problems on determinant. To better understand this episode, I suggest to visit a previous episode, then come back to this episode to better understand the concept of determinant. Let us move on to this episode. These are all the few questions we are going to discuss in this session. Find the inverse of the following matrix. If A is equal to 2 by 2 matrix and B is equal to another 2 by 2 matrix, we have to verify that AB the whole inverse equal to B inverse A inverse. Then similarly, if A is equal to 2 by 2 matrix, show that A square minus 5A plus 7I is equal to 0. We have to show that A square minus 5A plus 7I is equal to 0. We have to find A inverse. Then fourth question and fifth question. Last two question is very important. For the matrix capital A 3 2 1 1, A square plus A into capital A plus B into capital I is equal to 0. We have to find the unknown variable A and B. Now prove that determinant A inverse is equal to 1 by determinant A if A is an invertible matrix. Let us move on to this episode. So first question, find the inverse of the given 3 by 3 matrix. Previous episode we have discussed how to find minor, cofactor and adjoint. With the help of these three concepts, we are going to find the inverse of the given 3 by 3 matrix. To find inverse of the given matrix, let the matrix be capital A. Let the matrix be capital A. I am giving one name for this matrix, capital A. To find A inverse, if you want to find A inverse, first of all, the given matrix determinant A should not be equal to 0. Then we can say that A inverse exists. A inverse exists. That means if the given matrix of determinant A is not equal to 0, then A inverse exists. You can find the inverse of the given matrix. That means the given matrix has to be a non-singular matrix. Yes or no? Determinant A is not equal to 0. That means non-singular matrix. So, if you want to find the inverse of the order 3 by 3 matrix, or if you want to find the inverse of the any matrix, determinant A should not be equal to 0. Determinant A not equal to 0. That means the given matrix has to be a singular matrix. Then you can say that A inverse exists. How to find A inverse? The formula is A inverse is equal to 1 by determinant A into adjoint vector. 1 by determinant A into adjoint A, where adjoint A is nothing but transpose of the cofactor matrix, CFM transpose. Previous episode we have seen adjoint A. So, if you want to find the inverse of any matrix, first you have to check whether the given matrix is non-singular or not. If it is a non-singular, that means determinant A is not equal to 0, then A inverse exists. To find A inverse, the formula is 1 by determinant A into adjoint A, where adjoint A is nothing but transpose of the cofactor matrix. Is it clear? Let us move on to this problem. So first you have to check determinant A is not equal to 0 or not. Determinant A is equal to that means expanding the first row, alternating plus minus. So 1 into, directly I am writing 1 into 4 2s are 8 minus 3 2s are 6, 8 minus 6. Now minus plus minus plus. So again 4 plus 1 into plus 1 into 4 zeros are 0 minus 3 into minus 3 minus 9. So plus 9. Now plus 2 into minus 2 into 0, 0 minus 6. This or no? That is 1 into 8 minus 6 is 2 plus 9 plus 2 into minus 6. So 2 plus 9 that is 11 minus 2. So that is 11 minus 12 is nothing but minus 1, which is not equal to 0. Which is not equal to, that means determinant A is not equal to 0. Therefore, the given matrix is a non-singular matrix. You have to write this sentence. Since this sentence you have to write. Since determinant A is not equal to 0, therefore A inverse exists. A inverse exists. It's very important sentence. You have to write this sentence. Since determinant A is not equal to 0, therefore A inverse exists. To find A inverse, to find find A inverse. Isn't it? M11, M12, M13, M21, M22, M23, M31, M32, M33. That is minor. Cofactor matrix you have to find out. Then cofactor matrix of transpose is nothing but adjoint A. Apply to the formula, you can find the inverse of the given matrix. Is it clear? So to find A inverse, just go through this. We'll find minor and cofactor. No, just go through. Minor M11. So first row, first element I am going to find with respect to the minor. So that is nothing but 2 minus 3 minus 2 4. Yes or no? 4 2s are 8 minus 6. 8 minus 6 is 2. So M11 is nothing but 2. Yes or no? M11 is nothing but 2. M12 according to this element. So 4 zeros are 0 minus 3 into minus 3 minus 9, 0 plus 9 is nothing but 9. Now M13 according to this element, including this column, including this row, you have to eliminate the minus 2 into 0, 0 minus 3 2s are 6, 0 minus 6 is nothing but minus 6. So M13 is nothing but minus 6. What is M21? This element, to eliminate this row, this column I have to eliminate, this row, this column I have to eliminate. That 4 into minus 1 is minus 4 minus this row is 4 into minus 1 minus 2 into 2, that is nothing but 4. Minus 4 plus 4 is nothing but 0. M21 is 0. What is M22? This row. So this I have to eliminate these two. 4 into 0 0 minus 3 into minus 3 minus 1 0 plus 9 is nothing but 9. Yes or no? M23 this element. So I have to eliminate this row and this column I have to eliminate. This row, this column I have to eliminate. Minus 2 into 1 is minus 2 plus 3 into minus 1 is minus 3. So minus 3, so 3 minus 2 is equal to 1. Is it clear? Now M31, third row, first element. Very carefully you have to eliminate. Now third row, first element. That means third row I have to eliminate. First column I have to eliminate. Now minus 3 into 1 is minus 3 into minus 1. That is something like 3 minus 2 into 2. 4. 3 minus 4 is something like minus 1. Now M32. I have to eliminate this one. Now 4. Minus 3 into 1 is minus 3, minus 0 into 2 is 0, minus 3 minus 0 is minus 3. Now M33, third row, third element, I have to eliminate this one, 7 shape. So 1 into 1 minus 1, 0, 2. 2 ones are 2 minus 0. That is something 2. So these are all minus. So M11, M12, M13, M21, M22, M23, M31, M32, M33. According to this, you have to find out C11. What is C11? See, I have told you that since 1 plus 1 is nothing but 2. So 2 is even number or odd number? Even number. If it is even number, the minor will be same as the cofactor. So cofactor is 2. That means C11 is 2. What about C12? Since it is an odd number, I have to multiply minus with the minor. So minus 9. Yes or no? C13. 3 plus 1, 4. It is even number. So minor will be same as cofactor. So minus 6. Yes or no? Similarly, what is C21? C21 2 plus 1 is 3. Odd. Odd means minus I have to multiply. So here 0 means 0 only. Minus 0 doesn't mean meaningless. Now M22, that is C22. 2 plus 2 is 4. It is an even number. It will be same as the minor. Now C23, it is an odd number. I have to multiply with minus. So minus 1. Now C31, 3 plus 1 is 4. It is an even number. I have to write as it is what minor. So here minus 1 is minor. Cofactor also minus 1. C32, 3 plus 2 is 5, which is an odd number. I have to multiply with the minus. So it will become 3. Yes or no? Now C33, what is C33? 3 plus 3 is 6. It is an even number. I have to write as it is 2. This is nothing but a cofactor matrix. You know that cofactor matrix or a transpose is nothing but adjoint A. Yes or no? So C11, C12, you have to C11, C12 minus C13 minus 6. Now 0, 9, 1, so minus 1. Now minus 1, 3, 2, minus 1, 3, 2. cofactor matrix of the transpose is nothing but adjoint. I will take transpose of this, right? I have to take the transpose of this cofactor matrix. To take the transpose, that is interchanging rows and columns is nothing but transpose. So 2, 0, minus 1, minus 9, 9, 3, minus 6, minus 1, 2 is nothing but adjoint. Now what is the formula for inverse? A inverse is equal to 1 by determinant A into adjoint. What is determinant A value? 1 by minus 1. 1 by minus 1 into adjoint A matrix we have to write as this. This matrix we have to write as this. That is the answer. Is it clear to everyone? It's very important concept. Very much carefully you have to find out this minor as well as the cofactor. If any one value is wrong, the entire problem will wrong. Okay, so be careful whether finding that m11, m21, m32 according to that element, you have to eliminate the rows and columns and pick out the elements. It's very important. Minor and cofactor. Is it clear? This is the way you have to find the inverse. So if you want to inverse of the any matrix, if you want to find out the inverse of any square matrix, first you have to check whether the given matrix is non-singular or not. If it is a non-singular, that means determinant A is not equal to 0, then only you have to move on to the minor and cofactor to find the minor and cofactor. If it is a non-singular matrix, determinant A is not equal to 0, write this sentence. Since determinant A is not equal to 0, A inverse exists. Then to find A inverse, minor cofactor. Cofactor matrix transpose is nothing but adjoint A. Adjoint A you will get. Therefore, A inverse equal to 1 by determinant A into adjoint A. This is the formula for inverse. 1 by determinant A into adjoint A. Is it clear? Is it clear? Just go to this. Second question. 1, 0, 0. 0 cos alpha sin alpha. 0 sin alpha minus cos alpha. We have to find the inverse of the given 3 by 3 matrix. I am given one name for this matrix, that is capital B. So first you have to find out the determinant B. If it is not equal to 0, B inverse exists. Since determinant B is not equal to 0, that means minus 1. How to find determinant B? Along with the first row, I have to expand alternative plus minus. So plus 1 into. Now, minus cos alpha into cos alpha, minus cos square alpha, minus sin alpha into sin alpha, sin square alpha. If I am taking minus outside, this cos alpha, this minus will become plus. Yes or no? So this, if I am taking minus cos square alpha, minus sin square alpha, if I am taking minus outside, this will become plus. Then cos square alpha plus sin square alpha is equal to 1. So minus 1 into 1 is something but minus 1. So determinant B is equal to minus 1. That means determinant B is not equal to 0. B inverse exists. Yes or no? Now to find B inverse, minor m11, m12, m13, m21, m22, m23, m31, m32, m33. According to this, we have to find out the cofactor matrix. Cofactor matrix transpose is nothing but adjoint A. 1 by determinant B into adjoint B is the answer over here. Because we have a consideration matrix name is nothing but B now. That's why. So m11, what is minor m11? Minus cos alpha into cos alpha minus cos square alpha minus sin alpha into sin alpha minus sin square alpha. If I am taking minus outside, cos square alpha plus sin square alpha is nothing but 1. So answer is minus 1. Yes or no? So this answer minor is nothing but minus 1. Is it clear? Now m12 minus cos alpha into 0, 0. Minus 0 into 0. So m12 is nothing but 0. What is m13? Sin alpha into 0, 0. Minus 0 into cos alpha, 0. 0 minus 0 is nothing but 0. Now m21. Here it is also 0. Yes or no? Now minus cos alpha into 1. Minus cos alpha. Minus 0 into 0, 0. So answer is minus cos alpha. Yes or no? Now sin alpha into 1, sin alpha. Minus 0, so sin alpha is the answer for m23. What is m31? Sin alpha into 0, 0. Minus cos alpha into 0, 0. 0 minus 0, 0. Is it clear? Now sin alpha into 1, sin alpha minus 0 into 0, 0. So answer is sin alpha for m M32. Now what about M33? Cos alpha into 1 is nothing but cos alpha. 0 into 0 is 0. So cos alpha for M33. According to this, you have to find out C11, C12. What is C11? C11 is again minus 1. It is an even number. So minor will be same as the cofactor. That is nothing but minus 1. What about C12 is nothing but 0. C13 is also 0. What about C21? C21 is also 0. What about C22? C22. 2 plus 2 is 4. It is an even number. If it is even number, minor will be same as the cofactor. So minus cos alpha. Minus cos alpha. What about C23? 23. That is odd number. 2 plus 3 is 5. It is nothing but odd number. So minus, I have to multiply with the minor. So that is minus sin alpha. C23 is minus sin alpha. What about C31? C31 is also 0. What about C32? C32. 3 plus 2 is 5. It is an odd number. So that I have to multiply with the minus. So minus sin alpha. What about C33? C33, 3 plus 3 is 6, it's an even number, so that minor will be same as cofactor cos alpha. So what is cofactor matrix? Factor matrix, I am not writing C11, C12. Directly I am going to write the element. C11 minus 1. C12, what is C12? 0. C13, 0. C21, 0. C22 minus cos alpha. C23 minus sin alpha. Next, C31 0. C32 minus sin alpha. C33 cos alpha. So this is nothing but cofactor matrix. If I am taking the transpose of the given matrix, this is nothing but the adjoint A. Yes or no? Adjoint A, adjoint B. Sorry, it is not A, adjoint B, because the given matrix is, we have made it as B. So this is nothing but B. No. What's the transpose of the given matrix? Minus 1, 0, 0, minus 1, 0, 0. Then next one, 0, minus cos alpha, minus cos alpha, minus sin alpha, 0, minus sin alpha, cos alpha. This is nothing but transpose of the given matrix. Minus 1, 0, 0, 0 minus cos alpha, 0 minus cos alpha minus sin alpha, 0 minus sin alpha cos alpha. This is nothing but transpose of the cofactor matrix, that is adjoint B. So therefore B inverse is 1 by determinant B into adjoint. Yes or no? What is determinant B value over there? Minus 1. So 1 by minus 1 is nothing but minus 1 into adjoint B. You can multiply with minus or keep it as it is. Is it clear? Is it clear? This is the way you have to find out the inverse of the given matrix. Let's go through this.